Good morning. Welcome to Math 098. We are going to continue working through our guided notes for Unit 1. Last class we started talking about fractions. We started talking about what it looks like to reduce fractions as well as multiplying fractions. So as a reminder, when you reduce fractions, you're looking for a common factor. You're saying, what factor does the numerator and denominator share that we can divide out, thus reducing or simplifying that fraction? When we hit multiplying fractions, we learned that we can reduce or simplify across fractions as well, so long as these are connected by multiplication. That's incredibly important. One of the things I wanted to really harp on was the fact that you do not need an LCD when you multiply fractions. So if you tend to get into that little like, what do I do here? Please do not use an LCD when multiplying fractions. You don't use it in this case. You don't need to find the lowest common denominator. You will focus on finding the lowest common denominator when you are adding or subtracting fractions, not when you're multiplying and not when you're dividing. Okay. So we're going to continue in our notes, and let's look at dividing fractions and see what's up with that. So dividing fractions rules. Now, when you think about multiplying fractions in the whole process, dividing is just one step prior to that. So in order to divide fractions, the very first thing you must do is the following. You must rewrite the expression. For example, you can see number 1. You're going to rewrite the expression as the product. Product means multiplication, right? It's a clue to indicate, it's a key word that indicates multiplication. So rewrite the expression as the product of the first fraction by the reciprocal of the second fraction. So what in the heck does that mean? I'm not sure if you've ever heard in the past something called keep, switch, flip. But I wanted to have written in words what that means, that mnemonic, keep, switch, flip, what that actually means. So to demonstrate that, I'm going to start by applying rule number 1 to our first example problem here. So the first thing we're going to do is we're going to rewrite it as the product of the first fraction, excellent, thank you, Alexis, as the first fraction, 58 over 20, times the reciprocal. Reciprocal means flip the fraction, right? No worries, Kevin. Stick with us, and hopefully that technology will end up coming back or actually working. So we'll multiply by the reciprocal of the second fraction. The really great thing about this is once you applied step number 1, bam, you're back into the rules of multiplying fractions. So we're going to go ahead and we're going to look for common factors. So you can do this by simplifying the fraction itself. I mean, notice 58 and 20, we can definitely divide by 2 at least, right? We have 12 and 38, we definitely can divide by 2. We could look at the 58 and the 38, they have common factors, and we could look at the 12 and the 20, they have common factors. This is completely up to you. I am going to choose to reduce the 12 and the 20 because I see that they're both divisible by 4. So why not? So 12 divided by 4 leaves us with 3. 20 divided by 4 leaves us with 5. So far, so good. Now, if we look at 58 and 38 at this point, I can say here, well, I definitely know these are even numbers, so I can divide by 2. Let's divide by 2 and check it out. So we have 58 divided by 2, which gives us 29. And then we have 38 divided by 2, which gives us 19. So let's rewrite this. We have 29 over 5, and we have 3 over 19. Can we reduce further? I don't know. Let's take a look. 3 and 5, definitely not. 3 and 19, 3 cannot go into 19, so that's definitely not happening. 29 and 5, 29 and 19, no. So because we cannot simplify further, we are now ready to just multiply from left to right. Recall from last class that when we multiply, we simply move from left to right. That's all we have to do. So numerator times denominator times over denominator times denominator. So we have 29 times 3 which gives us 87. And we have 5 times 19, which is 95. If you have successfully completely reduced up front, your answer will be completely reduced as well. To demonstrate that to make sure that we are in fact in the right place, we're going to punch in 87, ABC, to tell our calculator it's a fraction, 95, and let's press enter and see if it reduces. Nope. Gives us the fraction right back, which means it is in complete reduced form. All right, beautiful. Let's turn the page. Number 1, perform the indicated operations. So take a look at our first problem here. Whoa, what does this say? Okay, well, if you look closely, it says 12 divided by 4/5. If that looks weird to you, why don't we just rewrite it? So this is actually 12 divided by 4/5. As a reminder on this one, anytime you have a whole number, why don't we write it over a 1? Because we're working with fractions, so why not? Make things nice and easy to kind of see for ourselves. Recognize we have a division of fractions problem, so it would make sense that our next step would be to keep, switch, flip. Rewrite the first fraction and multiply by the reciprocal of the second fraction. Keep, switch, flip. At this point, all we have to do is try to reduce. So notice here we have the 12 and the 4. So it makes sense to divide both by a 4. So 4 into 4 is once, and 4 into 12 is 3 times. Notice that we cannot reduce further numerator for denominator, so we're simply going to move from left to right. 3 times 5, which is 15, over 1 times 1, which is 1, which we would simply write as 15. Okay, we're going to make it as nice and neat as possible. What I would like you all to do is to kind of play around with both of these ideas, multiplication and division of fractions, and try problem number 2. Let's see what you all come up with. I'm going to give you a few minutes on this one because it's kind of tricky. So 3 minutes starting now. All right, so we have several answers coming in, and they all are exactly the same. So we are all noting in the chat that the answer should be 18 over 85. Let's prove that. Now, I'm curious. I wish I could see your work for this kind of a problem, because I'm curious as to how you went about getting that answer. Johanna, Ashanti, Hannah, excellent. So let's take a look. I'm going to show you a perspective that I personally would take in solving this particular problem. So theoretically, because we have a set of parentheses, according to the order of operations, or PEMDAS, we would take care of whatever operations were inside the parentheses first, right? Okay, so Claire agrees with that. We would start with the parentheses. Now, I'm just going to shake things up a little bit. Because I have experience and because I want to apply the rules for division of fractions. Check what you're allowed to do. Check this out. Notice I have my first quantity divided by my second quantity. Okay? Because we have this product packaged in parentheses, this is essentially my first expression divided by my second, right? So what I'm going to do is I'm actually going to apply keep, switch, flip. I know it sounds crazy, but you're allowed to do this. We're going to keep, switch, flip. So that gives me 14 over 25 times 9 over 17 times 15 over 21. Even if you simplified what was inside the parentheses first, you would still end up having to multiply by the reciprocal. Don't you agree? Now, by opening this up, And by ensuring that I am not changing the actual integrity of the problem, all I did was apply the rule for division of fractions. Now I see, wait a second, I have some common factors here and here. So exactly, Hannah, sometimes it's interesting to kind of play around with the rules of mathematics, right? Like what it is that we're actually allowed to do based on the information that we have. So I would personally rewrite it first, and now check this out. 15 and 25, I'm definitely going to divide both by a 5. So 5 goes into 15 3 times, and 5 goes into 25 5 times. Then remember, I'm just kind of playing around and looking at reducing the first things that jump out at me. I notice here I have a 14 and a 21, numerator, denominator. So if I'm looking at this 14 and 21, the 7 is jumping out, right? 7 goes into 14 twice. 7 goes into 21 3 times. Let's rewrite. It's a little messy. 2 over 5, 9 over 17, 3 over 3. Okay, in this case, right away, my eyes are drawn to this 3 divided by 3, which will leave us with 1s. Simplifying all the way leaves me with, you guessed it, 18 over 85. How cool is that? Sometimes just playing around with these ideas here can lead us to an answer in a much simpler form. But the other side to this is, even though you may have taken a different approach, we got the exact same answer, which really means that you know your rules, that you know exactly what you're doing, and that is fantastic. Very nice. I love showing different paths towards the same answer. I'm really, really big on that. Let's look at adding and subtracting fractions. So here's the place where we sometimes tend to do things that we really shouldn't be doing. I've seen students try to reduce numerator for denominator across addition or subtraction, and that's a huge no-no. If you can be really, really, really focused on splitting up all those rules depending on what the operation is, you're going to be golden. Think about the fact that multiplication and division, that's kind of like their own group, right? Whereas addition and subtraction is its own group as well. So when you think of adding and subtracting fractions, think LCD, lowest common denominator or lowest common multiple. We'll talk about that in a second. And when you think of multiplication and division, think of division having that first little step, keep, switch, flip, and then focus on reducing numerator for denominator and then just multiplying straight across. Okay? It doesn't take much. Just keep playing around with it until you're an expert at it. To add or subtract fractions, we got to find the LCD first. If the fractions do not have the same denominator, you need to find one. When you think of this process, it might be helpful if you think of finding the LCM, the lowest common multiple. So in this case, what I want you to consider is that by finding the LCD, you're actually finding the lowest common multiple. Now, as a recap, multiples look like this. So for instance, let's say I had the number 5. Multiples of 5 are 5, 10, 15, 20, 25, etc. So these are multiples, very different from factors. Okay? So you're first going to look at the fractions that you have and you're going to say, well, what's their lowest common multiple, right? I put a note here. If you can't seem to find the lowest common denominator, the lowest common multiple, there's a shortcut. You can always just take the denominators, multiply them together. Even if you have 3 fractions all being added or subtracted together, you could take the denominators, multiply them all together, and that would be a common denominator. It might not be the lowest, but it'll definitely be a common denominator because they all share it, right? If you multiply them all together, then they share the same factors. So keep that in mind if you're ever feeling stuck. Once you identify a common denominator, you're going to multiply each fraction by the missing factor to result in that common denominator. So let's take a look at this first one. We could say that with 11 and 77, we're unsure as to what the denominator is, so we multiply them together and we say 847 is common to both. True. I totally agree. It's not the lowest, and I would assume that most of you can see that the lowest common denominator, or the lowest common multiple in this case, is going to be 77, right? Taking a look at 11, its multiples are 11, 22, 33, 44, all the way to 77, and then so on and so forth. And with 77, you start here, and you're like, oh, there it is. That's their common multiple, the lowest common multiple. So we have to decide what to multiply each fraction by. Consider that we want our 11 to become a 77. It is not okay to simply say, oh, we're just going to multiply the denominator and leave the numerator. By doing so, you are not creating an equivalent fraction. That is incredibly important. Let me show you what I mean. First off, to create an equivalent fraction, we want to multiply by 1. And you're probably thinking, wait, what? You wrote 7 over 7. 7 over 7 is 1. Don't you agree? So 2 over 11 times 7 over 7, and 7 over 7 is 1, will give you 2 over 11, right? But in a different form. I'm going to prove it to you. So we have 2 divided by 11. That gives us 0.18, 0.18, 0.18, 0.18 repeating, okay? So now I'm going to consider when I multiply by 7, this gives me 14 over 77. Take the same fraction, 14 divided by 77, 0.18, 0.18, 0.18, etc. So we note that we did not change the problem, we simply changed the way that the fraction looked so that we can actually combine it with our second fraction. If you would like, you can write times 1 over 1. That's totally up to you. We don't need to actually multiply by anything in our second fraction because it has that common denominator. Another note, you may want to actually jot down what that LCD is. It tends to kind of help give us a guide, be like our focus. We know that our denominators have to become that number, so we have to do what it takes to make that happen. Once you have identified the common denominator and adjusted both of the fractions by multiplying by the missing factor, all you have to do now is add or subtract across the numerators. So we add across the numerators, 14 plus 5, which is 19. And you keep the denominator. 77 is our denominator. Think of it as 14 out of the 77 pieces plus another 5 out of the 77 pieces means we have 19 out of the 77 pieces. Think of this visually too if that's helpful. Our last step, as always, check to see if your fraction can be reduced. Luckily, the 19 over 77 cannot actually be reduced. We can double check, always double check. 19, ABC 77. You guys are going to get so fast at this. It leaves us with a 19 over 77, and we're golden, and that's our final result. 19 over 77. Refrain from writing the decimal form. Leave it in fraction form. Okay? All right. This blurb down here is essentially a recap written down of what I described with the multiplying by 7 over 7, multiplying by 1. Okay. Let's turn the page. Our instructions here are to evaluate, so we want to make sure that we write our answers in simplest form. Taking a look at number 1, negative 3 and 8/9 plus 2 and 4/5, I'm going to suggest that we rewrite these in improper fraction form. Right now they're mixed numbers. I suggest we rewrite them. So in the chat, would you do me a favor and tell me what do both of these mixed numbers become in improper fraction form? Beautiful. So we have some answers coming in here. Noelia and Claire, let's take a look. So we have for this first one, 9 times 3, which is 27, plus 8, which is 35. So this is going to be a negative 35 over 9. And then we have 5 times 2, which is 10, plus 4, which is 14. So we will have 14 over 5. Excellent, Hannah, Keith, thank you for also contributing to the conversions. So we have 14 over 5. Beautiful. Thank you, Alexis. So now that we have negative 35 ninths plus 14 fifths, we are saying, okay, we are adding or subtracting fractions, which means we need a lowest common denominator, in which case is the same as the lowest common multiple. If you had to state what your LCD is, we could write out all the multiples of 9 and 5, but I think you all are seeing that 9 times 5 is 45, which actually in this case happens to be the lowest common denominator. It's a nice, easy way. Just multiply those out, see what it gives you, and go from there. That will always work, even if it's not the LCD. It's still a CD, like I said before. So we want our denominators to become 45. So essentially we say, okay, if I want that 9 to be a 45, well, I have to perform an operation, and that is multiply it by 5. But what you do to the denominator, you must do to the numerator. Remember that you are essentially multiplying by 1. So now we have 5 times a negative 35, which is going to give us negative 175. So far, so good? Next, we're going to adjust the second fraction by doing the same idea. So we want our denominator to be 45, which means we're going to multiply by 9. What you do to the denominator, you do to the numerator. Remember, we're multiplying by 1. And I'm going to continue to say that until it's completely like burned into your minds. In a very positive way, of course. So now we have negative 175 over 45 plus 126 over 45. Consider the rule is to combine your numerators and keep your denominator. So we're going to leave our denominator 45, and we're going to punch in exactly what we see from left to right. So negative 175 plus 126. Negative 175 plus 126, and that gives us negative 49. By looking at these two, we could say, is there anything we can divide out of both? Typically, when you think of 49, 7 times 7, right? Can 7 go into 45? Definitely not. It still doesn't hurt to do a quick check, punch this into your calculator, and say, oh, it gives me a mixed number. I don't want this mixed number, so check this out. When I typed my fraction in, my improper fraction, it gave me a mixed number. Negative 1 and 4 over 45. Okay, cool, but I don't want that. Notice above this ABC key, it says ABC to DE, but it's in yellow. So if I want to activate this function, I must press the yellow key. So I'm going to press yellow, that key to go from mixed to improper, and I press enter. And you get it back. Voila, we're done. Your turn. Do number 2. This time I'm going to give you exactly 60 seconds. Let's see what you got. This is fantastic. You're all super, super fast. Major, excellent. Very nice. I love it. So right away, we're looking at negative 121 over 14 plus 33 over 7. All of you are putting in these answers. I love it. Let's check it out. So notice here we have a 14 and a 7. I want you to consider the LCD in this case is definitely going to be a 14. If that idea is weird, just think about it logically. We start with 14, 28, etc. We have 7, 14, 21, etc. And we see that the common multiple of both 14 and 7 is 14. The nice thing about that is that just implies that we have to multiply the second fraction by 2's. So 2 over a 2. That leaves me with negative 121 over 14 plus 66 over 14. We've created equivalent fractions by multiplying by a 1. At this point, we have negative 121 plus 66. We combine those to get negative 55, and you keep the denominator, which is 14. Always do a double check to see if you can reduce that, And luckily for us, we actually cannot. Negative 55 over 14 is as reduced as it gets. Okay. I'm going to give you a shot at number 3. Enjoy. Okay, let's take a look at this craziness. So as I examine 5 2/3 minus 28 over 14 plus 1 1/5, the first thing I would recommend is let's convert from mixed number to improper fraction form. So I'm going to make a note here, convert mixed to improper. That's the first thing I'd probably do, right? Kevin, that's a great question. Keep in mind that keep, change, or keep, switch, flip, or keep, change, flip idea only applies to division. For this particular problem, notice that we are subtracting and adding fractions. That's okay. That's okay. So let's convert mixed to improper first. 5 2/3. We have 3 times 5, which is 15, plus 2, which is 17. So that gives us 17 over 3. We have minus 28 over 14, plus, and then same thing here. 5 times 1, 5, plus 1, which is 6 over 5. Now, Patrick had commented in the chat, honing in on the 28 over 14. You are all going to hate me when you see what I'm about to do. That 28 over 14 actually reduces. If you took 28 and you punch it into your calculator divided by 14, dun, 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 it's a 2. So I'm actually going to reduce this fraction. Remember, if your work had that fraction 28 over 14, you'd be like, oh yeah, I can reduce that. No, I put this problem here because I want you all to see that sometimes you have to be critical about the actual problem itself before diving into like all of the operations. Sometimes we just have to take a step back and say, okay, what's happening here? What can I do to simplify this for myself before moving forward, if possible? And in this case, you could, but it's not something you look for. But I want you to start looking for that, okay? So as you're doing these problems, start to think about, can I make my life easier up front? Can I do something up front? If not, okay, then you go through the process. But if you can, golden. Let's take a look. So 28 over 14, well, that just becomes a 2 over 1. So I'm going to rewrite this. Now we have 17 over 3 minus 2 over 1 plus 6 over 5. Now, because we have fractions here and because we're adding or subtracting, we definitely need to find the LCD. So, Kayla, we will multiply each of these fractions by a quantity, but we have to figure out what that is. Notice we have a 3, a 1, and a 5. So our common multiple is going to be 15. Once I know what my LCD is, I simply multiply every fraction by the factor that is missing to ensure that my denominators are all 15. So think of it this way. We know that the denominators must be 15, right? So it's almost like I'm writing the fractions in there and then I'm going to adjust them. So to make this happen, I had to multiply my first fraction by 5. So we have 5 times 17. Well, that gives me 85. Our second fraction, we need to turn this 1 into a 15. Well, we do that by multiplying by 15. What you do to the denominator, do to the numerator. 2 times 15, 30. Lastly, we want to go from 5 to 15. That means we have to multiply by 3. What you do to the denominator, do to the numerator, and that gives us 18. The great thing about this is all we have to do now is move from left to right. So we have 85 minus 30, which is 55, plus 18, which is 73. So our final answer is 73 over 15. As a reminder, always try to reduce if possible. In this case, the 73 ABC 15, it actually does not reduce. So we're going to leave it as is. Okay? Any questions on that for me right now in the chat? While you pose your questions, I actually want to show you what it looks like if we didn't reduce the 28 over 14. Because, you know, we might not see it, and that's okay. So I'm going to move to my scrap paper, and let's take a look. So we have 17 over 3 minus 28 over 14 plus 6/5. Okay. If we were unsure, or if we didn't realize that 28 over 14 reduces to 2, we can look at all of our denominators and say, okay, well, 3 times 14 times 5, that's 210. And we could say, you know what? Let's call our lowest denominator, in this case, 210. Okay. So because we want all of our denominators to be 210, you're probably thinking, that's really huge. You have calculators. You have tools to help you through this process. So don't freak out, and that's okay. So let's take a look. If we want our common denominator to be 210, well, we know that 3 times 14 times 5 is 210, which means in order to make this 3 into a 210, we want to multiply that by the 14 and the 5. But 14 times 5 is 70. So we're going to multiply the denominator and the numerator by 70. I know it looks crazy, but don't panic. I know the craziness that this looks like. It's okay. For the second one, notice to get the 210, we took the 14 and we multiplied by the 3 and the 5, right? That's how we got 210. So 3 times 5 is 15. So we're going to multiply the denominator and the numerator by 15. So 28 times 15, let's take a look. 420. Lastly, we want 5 to become 210, and we know that 5 times 14 times 3 is 210. So 5 times 14 times 3 and 14 times 3 is 42. So we'll multiply numerator and denominator. So 42 times 6 gives us 252. At this point, as crazy as that looks, we still have our tool. So I'm going to take 1190 minus 420, add 252, and that gives us 1022 over 210. Now I'm hopeful that you look at that and you're like, ah! And you say, okay, that has to be reduced. So let's take the 1022 over 210, 1022 ABC 210, and let's reduce it. We get 4 and 13 over 15. Okay, I don't want to mix number. We're going to press second ABC, and voila, 73 over 15. Even though we go through a lengthier process here in terms of the actual values that we're getting, the math never changed. The process stayed the same. And at the very end, we just made sure to reduce so that we would have the exact same answer from our problem when we did reduce that second fraction. Not bad, right? Excellent work today. Bye.